Hello students, now I am Dr. Pradipin Kumar Mahapatra, Vedang Institute of Technology. Now we are going to discuss Laplace transform. So already I told you in a Laplace transform on a basic function of Laplace transform already I told you in a previous lecture 1, 2, 3. So again I will recall this one, that is your Laplace transform of different functions. When we are going to find out the Laplace transform of some basic functions, so already I told you in a Laplace transform of f of t, that is your what? That is your f of s, and there is a standard formula to find out the Laplace transform of any function, that is your 0 to infinite, that is your f of t into e to the power minus st dt. This is your standard or basic formula to find out the Laplace transform of any functions. So if f of t is a function, to find out the Laplace transform of f of t, and the formula is that what? 0 to infinite f of t into e to the minus st dt. So already I told you some basic functions like your constant functions, Laplace transform of constant function k, that is your what? K by s. Already we have derived how to find out the k by s. Similarly, the Laplace transform of some exponential functions or some time domain, that is your t, that is your 1 by a square. And similarly, Laplace transform of t to the power n, that is your factorial n divided by s to the power n plus 1. This is nothing but your basic standard formula to find out the Laplace transform of any time domain functions. If n equal 1 and the value of n equal 1, that is your s 1 by a square. Similarly, if t square, if n equal to 2, factorial 2, that factorial 2 is nothing but 2 into 1, 2 by s cube. If I will say Laplace transform of t to the power 3, if n equal to 3, so Laplace transform of t to the power 3, that is your what? Factorial 3 divided by s to the power 3 plus 1, and it is nothing but 3 factorial is your 3 into 2, that is divided by s to the power 4, and it is equal to your 6 by s to the power 4. So in this way you will find out the Laplace transform of any time domain functions. So suddenly you require the Laplace transform of t square, t cube, or t, any power of t, you can use this formula t to the power n equal to factorial n by s to the power n plus 1. And already we have derived how to find out the Laplace transform of some constant functions or some time domain functions. So then we have discussed the Laplace transform of, that is your exponential functions. The Laplace transform of exponential function like e to the power plus at, a is a scalar value, so e to the power at, that is your 1 by s minus a. We have derived in a previous I think lecture 1 or lecture 2, e to the power at, any exponential function of Laplace transform. So Laplace transform of e to the power at equal to 1 by s minus a. If it is a plus, and it will be minus. Similarly, Laplace transform of e to the power minus at, and it is equal to your 1 by s plus a. And similarly, these are nothing but an exponential functions. So frequently you will find when you will solve any type of network, if you apply the Laplace transform, some basic standard formula you have to keep in your mind. If it is an exponential function like e to the power at, if it is plus, and 1 by s minus a. If it is minus, e to the minus at, that is 1 by s plus a, where is in constant value. Similarly, Laplace transform of sinusoidal functions. If f of t equal to that is your sin h omega t. In a hyperbolic function, and Laplace transform of sin h omega t is nothing but what? That is your omega divided by a square minus omega square. Similarly, Laplace transform of cos h omega t, that is your what? That is your s divided by a square minus omega square. So these are the basic things. Always when you are apply the Laplace transforms of any DC networks or DC or AC, if you apply the Laplace transform, you certain formula you have to keep in your mind. If maybe your time domain functions, or maybe exponential function, or maybe your sinusoidal functions. As far as sin h omega t, cos h omega t, if in a sin value, and numerator must be omega. If it is in cos value, the numerator must be s and the denominator must be same. Similarly, if I will say the Laplace transform of sin omega t, if sin omega t, it is nothing but what? That is your omega by a square plus omega square. In hyperbolic function, always remember the denominator must be minus. If any sin omega t, it will be plus a square plus omega square. Similarly, if I will say Laplace transform of cos omega t, that is your what? That is your s by a square plus omega square. So denominator must be same, a square plus omega square. Thing is, if it is cos function, the numerator must be s. If it is a sine function, numerator must be, that is your omega. So all these things already I told you in the previous lecture 1, 2 and 3. So already derived how those e to the minus at becomes 1 by s plus a, or e to the power plus at, that is your 1 by s minus a. How hyperreal functions, sine and cosine functions are may obtain omega by a square minus omega square, or s by a square minus omega square. All the parts already we have discussed. So that is your so now today we'll discuss, that is your shifting theorem. It is very important as far as shifting theorem. In a shifting theorem or shifting property. What is shifting property as far as your Laplace transform is concerned? What is shifting property? You know what is the Laplace transform of f of t, that is your f of s, or you know Laplace transform e to the power at, that is your 1 by s minus a, or e to the power minus at, that is your 1 by s plus a. In shifting property, the property is what? If Laplace transform of f of t is your f of s, then what? Then Laplace transform of e to the power 80 f of t, e to the power 80 plus 80 f of t, Laplace transform is nothing but what? F of s minus a, or Laplace transform of e to the power minus 80 f of t, that is your what? F of s plus a. It is very important when you are going to apply the Laplace transform, both exponential function. If e to the power 80 or e to the power minus 80 is given, a may be positive or a may be a constant value, maybe 1, 2, 3, 4, etc. And if any function multiplied with some exponential function, the time domain function f of t Laplace transform f of s, that is your s can be shifted to what? If it is plus a, the f of s can be shifted to f of s minus a. If e to the minus a t multiplied to f of t, the function shifted to, that is your what? F of s plus a. Okay. So let us prove. Suppose to prove what? We have to prove Laplace transform of e to the power 80 f of t. Here f of t, that is your what? Laplace transform this. So Laplace transform of any function, the value is how much? The proof, that is your what? 0 to infinite, that value, what? E to the power 80 f of t into e to the power minus st dt. When you are going to find out the Laplace transform of any function, we are going to find out the Laplace transform of e to the power 80 f of t. E to the power 80 is multiplied with f of t. When you are going to find out the Laplace transform of this one, that value, the formula is what? The formula is what? The Laplace transform of any function, the formula is what? 0 to infinite f of t into e to the power minus st dt. That is what? F of s. F of s is nothing but what? Laplace transform of f of t. So when you are going to find out the Laplace transform of f of t, that value into e to the power minus st dt. Similarly, we are going to find out the Laplace transform of e to the power 80 f of t. So e to the power 80 f of t, that value into e to the power minus st dt is our standard formula to find out the Laplace transform of e to the power 80 f of t. Then what we will do? That is your 0 to infinite e to the power, here e to the power 80 into e to the power minus st. The value is how much? If same base, that will be add it, that is your what? Minus what? S minus a into t into f of t dt. The value is how much here? If f of s means what? E to the power minus st. If it is minus coefficient of minus t is what? S. That's why this f of s. Similarly, the coefficient of minus t, f of t dt, coefficient of minus t is what? S minus a. The value is, whole value is nothing but what? F of s minus a. So therefore, if e to the power 80 f of t, Laplace transform of e to the power f of t is nothing but f of s minus a. Similarly, Similarly, Laplace transform of e to the power minus a t f of t, e to the power minus f of t is how much? That is your 0 to infinite. That is your what? This value e to the power minus a t f of t into e to the power minus st dt, and it is nothing but what? 0 to infinite, and this value will be added x e to the power same base. That's why e to the power minus s plus a into t into dt. The value is how much? F of s. S means what? F of t dt, and the e to the power minus t coefficient is how much? S. That's why it's f of s. Similarly, e to the power minus t coefficient is what? That is your s plus a. This is your what? S plus a, and the value is how much? And the value is how much? This is nothing but f of s plus a. E to the power minus st dt is must e to the power minus st. If it is minus st means s means f of s. E to the power minus st, s is nothing but s plus a. That's why f of s plus a. Here that is your minus t. This is your what? S minus a. This is nothing but f of s minus a. So that is all about your. But if any exponential function is multiplied with some function, then the function is shift f of s to s minus a. If it is a is positive, if f of s shifted to f of s plus a, if what? E to the power minus at. So that is all about your what? The if any function is multiplied with any exponential function multiplied with f of t. So already you know the Laplace transform of sin omega t, cos omega t, sin h omega t, cos h omega t, like this. If I will say that is your what? If I will say that is your Laplace transform of e to the power 80 cos omega t. E to the power 80 cos omega t is how much? F of t, here f of t is how much? F of t is your cos omega t. Here f of t is your cos omega t. F of t, here f of t equal to what? Cos omega t. Cos omega t. F of s is how much? F of s is your cos omega t Laplace transform is your s by s square plus omega square. So therefore, Laplace transform of e to the power 80 omega e to the power 80 cos omega t, e to the power 80 cos omega t is how much? Cos omega t equal to, if s f of t cos omega t, f of is your s by s square plus omega square. If e to the power 80 is multiplied cos omega t, already I told you in place of s the function is shifted to s minus a. If it is your 80 cos omega t, f of s minus a, in place of s you will put s minus a. So cos omega t you know s by s square plus omega square. Since e to the power 80 multiplied with cos omega t, by using shifting property, then what? E to the power 80 cos omega t is nothing but what? In place of s, that is your s minus a, divided by, in place of s, that is your s minus a rho square plus omega square. This is nothing but e to the power 80 cos omega t. Similarly, if I will say that is your, if I will say e to the power minus 80 cos omega t, e to the power minus 80 cos omega t, e to the power minus 80 cos omega t, what you will do? E to the power minus 80 cos omega t. If I will say number 2, that is your Laplace transform of e to the power minus 80 cos omega t. The value is how much here? So if here f of t is your what? Cos omega t. F of s is how much? S by s square plus omega square. Since e to the power minus 80 multiplied, the function f of s shifted by what? If it is minus means s plus a. So that's why in place of s, that is your what? That is your s plus a divided by s plus a square plus omega square. So number 3, if I'll say Laplace transform of e to the power 80 sin omega t. Here f of t is how much? F of t equal to sin omega t. Since e to the power 80 multiplied, whatever the value of the sin omega t, f of s is how much? F of s equal to your, that is your omega divided by s square plus omega square. In case of sin omega t cos omega t, denominator is your a square plus omega square. In place of sine, the numerator must be omega. In case of cos, numerator must be s. So since e to the power at multiplied, the function shift what? The original function shift f of s to f of s minus a because it is positive. So f of s, so Laplace transform of e to the power at sin omega t is how much? That is your, in place of s, you will put s minus a square plus omega square. So this is nothing but your what? That is your, using shifting property, we can find out the Laplace transform of any functions, provided e to the power at, if e to the power at multiplied with any function, if at multiplied, f of s, put f of s to into f of s minus a. If e to the power minus at multiplied, and substitute f of s into f of s plus a. So thank you. For next class again we will do more and more problems.